Welcome back everyone to a session on big data analytics, and in today's session we will be looking into another chapter of module 4, which is regression. Regression, as I've already mentioned in the data mining chapter, is supervised learning. So I'll be having independent variables and dependent variables. So based on the value of independent variables, I should be able to calculate or predict the value of a dependent variable. So that is about supervised learning, and this is little different from a classification. So classification, normally we deal with the categorical value, and if we have a continuous value, then we need regression. For example, if I have to predict the stock price or a price of a house, then I cannot make use of classification, right? Because it is a continuous value. So I should be making use of regression. Okay, now let us see what exactly or how exactly regression works. Regression is a well-known statistical technique. So see, the techniques whatever we have seen are classified into either machine learning, are categorized into either computer science, that is computer science related, that is artificial intelligence or machine learning, or on the other way I have statistical methods, right? So regression falls into a statistical technique to model the predictive relationship between several independent variables and one dependent variable. So I can have multiple independent variables, so it is not necessary that I need several. Okay, I can have a single independent variable also. Okay, and based on that I should be able to predict the value of a dependent variable. So these are the x value and this will be the y value. Okay, so and the objective is to find the best fitting curve for the dependent variable. So obviously we'll be having a graph. Okay, so where we will be finding the relationship between the independent variables and dependent variables, and the objective is to find the best fitting curve in this graph. So we will be getting a clear idea once we look into some examples. And this curve could be a straight line or it can be a non-linear curve. Okay, and the quality of the fit of the curve to the data can be measured by the coefficient of correlation, which is known as R value. Okay, so this is very important. So what is correlation? Coefficient of correlation, it determines how strongly the independent variables and dependent variables are related. Okay, so how closely it is related. So based on R value, I should be able to measure that. Okay, then yeah, R is nothing but the square root of the amount of variance explained by the curve, which is known as R square. So if I have R square, I should be able to calculate R, and if I have R, I should be able to calculate R square. So these are the two measures of evaluating the model, or rather, see, the first one, R is mainly used to determine the quality of the fit. Okay, and R square is normally used to evaluate the goodness of the model that is used to predict the dependent variable. So the R square is normally represented in terms of percentage. So if I get 80%, then I'll 80 or 85%, then I'll be having a very good model which is 85% efficient. Okay, so coefficient of correlation, which is R, determines how closely the dependent and independent variables are related. Okay, and the variance, the square root, which is nothing but the square root of the amount of variance explained by the curve, known as R square, which determines the efficiency of the model. Okay, so these two matrices can be used to evaluate the problem statement and the solution what we have for this particular for the given problem. Okay, so with this, let us see the key steps for regression. Okay, so first one is list all the variables available for making the model. Then establish a dependent variable of interest. So identify what is the dependent variable, so which is normally represented as y, and examine the visual relationship between the variable of interest, that is the independent variable and dependent variable, if possible. Okay, it is not necessary that you need to examine visual relationship, because in a multilinear regression it is a little difficult to find the graph, because I'll be drawing a graph, or we will be drawing a graph to find the relationship between independent and dependent variable, where each dimension is represent, or each independent variable represent a dimension. Okay, so if I have more than one dimension or more than one independent variable, then it is a little difficult to draw the graph, and it is very difficult to visually examine the relationship, right? So if possible, we should be able to visually see the relationship between the variable of interest. Of course, it is possible when I have a single independent variable and dependent variables. Obviously, dependent variable is always one, and if I have a single only one independent variable, then I should be able to very easily examine the visual relationship between these two. Okay. Then find a way to predict dv using other variables. Yes. So which we will be learning very soon. And now let us see the correlations and relationship. Okay. So the first and foremost measure of the strength of a relationship is correlation. Okay. So this is not a new term which we have been learning from whenever, I mean, from the days when we know statistics, we have been looking into this term, right? Correlation. So this determines the how closely the two variables are related. Okay, and the strength of the correlation is a quantitative measure that is measured in a normalized range between 0 and 1, and the relationship can be either positive or negative. Okay, let us see what exactly a positive relationship and negative relationship is very soon with an example diagram. Okay, so therefore a good measure of the correlation is a correlation coefficient called as R, which can range from -1 to +1. Okay, so let us see what exactly a positive relationship or a negative relationship is. Okay, so with this diagram, okay, before that let us look into the formula for R square. Okay, so R square, as I have already mentioned, it represents a variance. Okay, and using which I should be able to calculate R value, and vice versa. If I have R, then I should be able to calculate the R square value, and this will give a very good idea, or it determines, it's a metric that that will determine how good the model is. Okay, in predicting the independent or predicting the dependent variable from the given independent variables. Okay, and this is the formula. R square is a summation of y hat minus y bar the whole square divided by the summation of y minus the y bar the whole square. So these terms, okay, so let me explain each of these terms. So what is y hat? Y hat is nothing but the predicted value, okay, or the output value that we have obtained from the model. So this is the predicted output value, and y bar is nothing but the mean value of the independent or dependent variable, and y is the actual value. Okay, so this is the actual value of the dependent variable. So these are the terms that comes in this particular equation, and using this formula I should be able to calculate R square, and obviously using the square root, that is I should be able to get R. R is nothing but the square root of R square. Okay, so this is nothing but this R will give me the coefficient of correlation, which will determine how good the relationship between the independent and dependent variables are, and R square will give me the variance, okay, which will be normally used to determine, it is normally represented in terms of percentage, so I should be able to evaluate the model using this R square. Okay, so using these two matrices I should be able to evaluate the solution. Okay, so this will give a clear idea regarding the positive and negative relationship. Okay, yeah, see, as you can see in this particular diagram, first one A, so this is a linear relationship, or a positive correlated relationship. As I increase the x value, the y value also increases, right? So I can form one line here, straight line. Okay, so that is in the linear, this is the line what I am talking about. So this is positively correlated. So in this diagram I have a positive correlation between the independent variable, which is normally represented as x, and the dependent variable y. Okay, and here if you observe the next one, that is B, I have a negative correlation. So negative correlation. So what can I say about this? If I increase the x value, the y value decreases. Okay, so this is so there is a relationship. I can find some relationship, but it is in negative way. So I can say that this is a negatively correlated data. Okay, data set. So these independent and dependent variables are negatively correlated. Then I have a curvilinear data. Okay, so as you can see, it is not a straight line, it's a nonlinear curve, and again which is in a negative way, right? So it is negatively correlated. Here also I have a curvilinear, so D is also curvilinear, a non-linear curve. Okay, so which is positively correlated. And see, if you observe E and F, you cannot find relationship. See, as the data is distributed all over the place, so it is not so this I can say that there is no correlation at all, right? So as I increase the x, y increases and also it decreases. So I cannot find any relationship. The same applies with F. Okay, so the same applies with F. Okay, now coming to R value, that is the correlation, as I said, which ranges from -1 to +1. So in this case, what if the value is +1? If the value is +1, then my graph is, or my data is perfectly correlated. So as I increase the x value in the same way, or with the same proportion, the y also increases. Okay, so I'll be having the data point exactly in this line. Okay, so here I'll be having +1 value. And what if I have a negative correlation? So in this way, yeah, so this is also with the same proportion. If I increase x value, the y value decreases. So here I'll be having a negative correlation, which is -1. So a plus and -1, or a high value, irrespective of whether it is positive or negative, so represent a very good correlation between a dependent and independent variable. Now what if the value falls in around 0? So 0 means there is no relationship at all. Okay, so if I apply the algorithm on this E and F, okay, I would get a correlation as 0, which indicates that there is no relationship between the dependent and independent variable. So I should be having a very high value, which should be close to +1 or -1. -1 for negative correlation, and +1 indicates positive correlation. So this is about the correlation, and this represents some of the linear and non-linear curves. Okay, so with which I should be able to predict dependent variable from the independent variables. Okay, now let us look into some regression exercise But before that, we should be knowing the formulas, right? How to calculate the or the formula for to calculate the dependent variable from the independent variable. So the formula, let us examine the formula first. So that formula is here. Okay. So y is equal to beta naught plus beta 1 into x plus epsilon. So let us examine each of these. So y, as I've already mentioned, is a dependent variable. So this is what we are going to predict. Okay, and it is dependent on these set of values. So first thing is I have beta naught, okay, which is the y-intercept in the graph, okay, and beta 1 is the slope coefficient, and x is nothing but the independent variable. So from which I should be able to, so the relationship is between y and x, okay, and these are some of the parameters that are required to calculate the y value, okay. And finally we have the random error, which is represented in terms of epsilon. Okay, with respect to graph, we will examine each of these, and the random error need not be used, so we can ignore the random error in our calculation, okay. But before that, we have to know what exactly beta naught and beta 1 represent in a graph. So I have a graph here, right? Okay, so see, as you can see, there are few plots. So what does this value represent? It represent 1 comma, so 1 from x-axis, and 2 comma 2 from the y-axis. So similarly, I have different plots. Okay, so what does this say? This, as you can see, it is the relationship is positively correlated, right? So there is a positive correlation between x and y. So I have y here, and there is a x. As I increase x value, the y increases, and this is the predicted linear curve what I got. Okay, so what does this represent? So this is the curve, or this is the line rather. Now for the value of x is equal to 3, it is predicting the value as 4, okay, and for the value 4, x value 4, it is predicting a value around 4.5. So this line, whatever the points we get in this line, is the prediction, okay. So this is the predicted, this represents the predicted values, this line, okay, and these dots represents the actual value, okay. This dots represents the actual value. Now what, okay, now in this formula, let us find the relationship between this formula and this curve. What and all things we need to calculate. Okay, so this, see, it intercept, this line intercept at some point, isn't it? So it intercept here at around 2.2. so what does this indicate? This is indicated by the beta naught, okay, so which is the y-intercept, okay. So this is nothing but beta naught, okay. Then the slope of this line is also very much crucial in determining the y value, so which is represented by beta 1, okay, beta 1. And finally we have something called as random error, which we will not be using in our formula in the future problems. So what does, but we should know what exactly this represent, okay. So as you can see, this is the actual value, right? So this is the actual value of y when the x value is 3, and this is the predicted value. So predicted value is 4, but the actual value is 5. Now there is a difference, isn't it? So there is a distance between, or there is a difference between this actual value and the predicted value. So this is called as random error, okay. So this difference is called as random error. So this is about the formula for a single independent variable which is used to predict a dependent variable. Similarly, we have formula, we can have multiple independent variables, right? So which is represented by these formulas, okay. Beta 1 into x, so this is basically the summation, okay. summation of the slope into the independent variable. So this is about the formula, and using these formulas we should be able to solve the problems. Okay, so let us solve few problems. Okay, as an exercise, I have a very simple problem. We'll solve this first, then we'll go into the problem that is there in the prescribed textbook. Okay, so here I have x and y. So these are the values of an independent variable using which I should be able to predict the value of the dependent variable y. I have 1, 2, 3, 4, 5, and these are the actual value of actual value of the dependent variable based on the value of the independent variable. So first thing first, we have to draw the graph. Okay, so we have to visually examine this, right? Yes, so the graph will look something like this. So I have x here, which is the independent variable, and the dependent variable y on the y-axis, and these are the plots, okay, which represent, see, this represents the first data, that is 1 comma or 1 2, okay, 1 on x-axis and 2 on the y-axis. So these are the 5 plots as per the 5 data points. Then we have to predict, isn't it? So how can we do this? Requires first thing, we have to calculate the mean. So mean is required, that is, we have to observe how far the predicted value is deviating from the actual value. Okay, so for that I require to calculate the mean of x and y. So if I add all these things, so this will give me 15. 15 divided by 5 will be equal to 3, and this, if I add, will be equal to how much? 6 plus 10, 20. 20 divided by 5, which will give me as 4. So this is nothing but the x bar and the y bar. Okay, so this is nothing but x bar and this is the y bar. So mean of x and y. Okay, then I'll plot that here. Okay, so as you can see, this is the 4 is nothing but the y bar value, and this is the x bar value, mean value. Okay. As you can see, this x and y, it intercepts at one point, isn't it? It intercepts at one point. So this point is very important, because the slope what we get will pass through this line. Okay, it will pass through this line. But now the biggest question is how to determine the slope of the line, and with the slope I should also be able to determine where the y intercepts, right? So it can be this one, it can be this line, isn't it? This line also passes through this intercept of x mean and y mean. Okay, and it can be this line also. So we don't know, right? We don't know. So for that we have to calculate the slope as well as the y-intercept value. So let us see how that can be calculated. First thing first, we should know the formula. So this is the formula what we will be using. As I said, I'll not be using the error, random error. Okay, so this is the intercept value and this is the slope. And to calculate the slope, yeah, I need to first observe the deviation, or I have to observe how the actual value is deviating, or how far it is from the mean value of x. Okay, so this is what I have to observe, and how the observation can be done. It can be done by finding the difference between the x and its mean value. Okay, where I can get a negative value also. So minus 2, see, this 3 is the mean, so 1 minus 3 is obviously minus 2. So this is how I get 2 minus 1, or 3 minus 2, or 2 minus 3 rather, gives me minus 1. Then 3 minus 3 will be equal to 0. 4 minus 3 will be equal to 1, and finally 5 minus 3 will be equal to 2. And if you observe one thing, if I add this value, then the summation will be equal to 0, right? Okay. Similarly, same way I have to observe how the actual values are deviating from the mean value of the y-axis, okay, or the mean value of the dependent variable. Okay, so this is the formula again: y minus y bar. Y bar is nothing but the mean value of this y, which is equal to 4. So these are the values: minus 2 0 1 0 1. So again, if you observe, I'll get a 0 value, right? If I add up, I'll get a 0. Then anyways, to calculate this distances, the entire calculation is done by using the concept of minimum square distance. Okay, so what we have to do is we have to square this distance. Okay, and this is the formula for the slope, okay, which is nothing but the summation of x minus its mean, x minus x bar, into y minus y bar, divided by the summation of x minus x bar the whole square. Okay, so for this, this is the formula for slope, right? So we need to calculate first this and then this, then we have to perform the division. So it is very simple. We just have to remember this formula. Okay, so yeah, so from beta 1 I should be able to calculate beta naught. We'll look into that a bit later, but first let us concentrate on the slope value. Okay, so this is x minus x bar the whole square. So I just have to square this, so I'll get a positive value. So I get 4 minus 1 square is 1 0, 1 square is 1, and 2 square is 4. Okay. Then I have to form the summation. I have to add this up, so which I'll get as 10. And similarly, I have to calculate x minus x bar into y minus y bar. So x minus x bar is here, and y minus y bar is also here. So I just have to multiply this. So minus 2 into minus 2, I'll get 4. Minus 1 into 0 is obviously 0. Here also 0 into 1 is 0. 1 into 0 is 0. And finally, 2 into 1 I'll get as 2. So if I add it up, then the summation value will be equal to 6. Okay, so based on this, yeah, so I have everything to calculate slope, right? So then now let us calculate that. So what I get is 6 summation 6 divided by 10. Okay, so this 6 divided by 10, which is equal to 0.6. So 0.6 is the slope value. So this is what we have calculated, okay, for this particular problem statement. Okay, now I have 0.6, and very easily I should be able to calculate the y-intercept. So let us see the formula. Okay, so what I will be doing is I will be making use of this formula. So that is b naught will be equal to y minus, see, I am bringing this, I am taking this value to the other side, right? So what do I get? B naught is equal to y minus b1 into x, and y, to calculate b naught, what we have to take is we have to take the mean value. So we already know what is the mean value of this, which is equal to 4, right? So and b1 value just now we have calculated, which is 0.6, and x here represent the mean value of x. So I'll be able to get this value, that is 4 into 4 minus beta 1 is 0.6 into the mean x value, which is equal to 3, which is nothing but 1.8. Okay, so 4 minus 1.8 is nothing but 2.2. Yes, so I got what? I got the slope value as well as I got the intercept value. So beta naught is also obtained, right? Now we can draw the graph, or we can draw the line rather. So this is the line what I get. As you can see, the y-intercept here is 2.2. So this is the y-intercept. So I should be able to calculate or draw this particular linear regression line. Okay, so half of the job is done, right? Okay, now we have to predict the y value, so which is done by, or which is represented by this symbol y hat. Okay, y hat, as I've already mentioned, is the predicted value. So what is the formula? The same formula I have to use, but I just have to change this y as y hat. So using this formula, I should be able to calculate the or I should be able to predict the y hat value. Okay, so y hat beta naught plus beta 1 into x. So for each row, these are the x value what I have to consider. Okay, and beta naught is 2.2 and beta 1 is 0.6, as we have already calculated. So the first for the first row, I'll get it as 2.8. okay, so if you want to cross verify, okay, let us solve this only this particular problem. Okay, then you can verify by yourself. So y hat, okay, beta naught, what is beta naught? It is 2.2 plus beta 1, which is 0.6, into x value, which is equal to 1. So what do I get? I'll get 2.2 plus 0.6, so which is equal to 2.8, and this is the value what I've entered here, 2.8. Similarly, I have to fill all this value, 3.8, sorry, 3.4, then comes 4, 4.6, and finally 5.2. So these are the predicted value. So this is what we are looking for from the model, and this is what we got. Okay, yes, so our answer is obtained. So if they ask for a given x value is equal to 10, what is the predicted y value? So very easily we can compute, right? So y hat, or the predicted y value, is equal to beta naught, which is nothing but 2.2 plus 10 into 0.6, which is equal to 6. So y will be 2.2 plus 6, which will be equal to 8.2. okay, so this will be the answer. So any further, if they ask if they give any independent variable x value, I should be able to predict the y value. But now we have to determine how good our model is, right? How good our how efficient our model is. So it is not enough if I simply calculate these value. I have to judge the model based on R square and R value. So for that, I require more calculation. Okay, so let us see. R square, as we all know, this is the formula. This is something what we have already seen. So I need summation of y hat minus y bar the whole square divided by y minus y bar the whole square. So we have all these terms, right? We got the y hat, we have the y bar, which is equal to 4, which was previously calculated. Then we have y value, y is also there, the actual value. So very easily I should be able to calculate. So what was missing? Y minus y bar the whole square. Of course, y minus y bar I have calculated previously. Now y minus y bar the whole square. So this is minus 2 whole square, 4, 0, 1, 0, 1, right? So this is what I get, 4, 1. So if I have to find the summation, I'll get it as, okay, so I need a summation, isn't it? Summation of this is it is 6. It is very simple. Similarly, y, yeah, so this is what we have calculated, 6. This is what I got. Now denominator I got, the numerator I require. Y bar or y hat is also, we have the y hat we have calculated, and y bar. Okay, again very simple, it is 2.8 minus 4, which will be minus 1.2, and similarly these are the values what I get. Now again I have to square it. So after performing the square, so this is the value what I get. Then now I have to find the summation. Okay, so this is already mentioned, it is 6 and here it is equal to 3.6. okay, so the numerator value is 3.6 and the denominator value is 6. Now what I have to do, I just have to apply it in my formula. 3.6 divided by 6, which is equal to 0.6. so my if I have to represent this in terms of percentage, then 0.6 into 100 will give me 60%. okay, so my model is 60% efficient, which is actually not that good. For a very good model I require at least 85. Above anything above 80 or 85 is considered to be a very good model, right? Based on this, from R square I should be able to calculate the R value. R square is 0.6, so R value is nothing but a 0.77. that is nothing but the square root of 0.6. so 0.77 is again it's not a good value, okay, or not the ideal value. Okay, see, from R square, one important point, from R square I should be able to calculate the R value, but we all know that R can be either positive or negative. So how will I, since the square root always gives me a positive value, how can I determine whether the R value what I obtained is positive or negative? It is very simple. You can very easily determine by the direction of this linear graph, right? Since I am increasing the x value, the y value also increases. So it is positively correlated. So I can very easily consider that this as plus 0.77 or simply 0.77. So this is what we get, right? So this is the evaluation. R square also is obtained, which is 60%. okay, 0.6 value I got, but if you have to represent it in terms of percentage, then it is 60%. Then R value is 0.77. Now with the clear idea how the linear regression works, now let us solve the problem that is there in the textbook. Okay, yes, so this is the problem that we have in our textbook, where they have given the size value, x value, that is the size area of the house, and this is the value that we need to predict, that is y value, which is nothing but the house price. Okay, so this is the dependent variable and size is the independent variable. So this huge data we have, right? So let us see how it works, or let us see the calculation which I will show in Excel. Okay, and I will also show how to calculate the linear regression using Excel. Okay, how to make use Excel as a tool to calculate the linear regression, and also to verify or to check the efficiency R, that is R value and R square value using Excel. Okay, for the problem what I have explained or what we have just seen, I have the solution here in my Excel. Okay, so this is x and y, where I have the independent variable and the dependent variable. So this is the independent variable size, and this is the dependent variable rather. Okay, so this is independent and this is the one what we have to predict. So this is the y value. Okay, let me change this into small letter y, because always we are representing the dependent variable as small letter y, right, and the independent variable as capital letter X. Okay, so these are the various size area, okay, in terms of area with respect to feet they have given, and this is the price with respect to dollar. Okay, so as we have solved the previous problem, first thing is I have to find the mean, right? So x bar, so this is the mean value using the formula. As you can see, it is the average of from here from this value, right? So this gives me the mean, and here also if you observe, it is average from B2 to B16, which is nothing but this range, the house price value range, okay, which is the mean value. So I got X bar and Y bar. Now I have to calculate, I have to observe the differences. So this is what we have done previously, X minus X bar. So these are the values what I get, okay. So X, this value minus the mean value, okay. And similarly Y minus Y bar, the value that is Y minus its mean, and these are the values what I get, okay. And what next? Yeah, then we require this, right? We need to calculate the Y value. So I require the slope and the intercept, that is beta value and beta 1 value. So for the beta 1 I require uh, these terms, that is X minus X bar into Y minus Y bar divided by X minus X bar the whole square. So first let us calculate these individual terms, okay. So X minus X bar the whole square, so that is what we will be calculating first. So very simple, this is as you can see, it is multiplied into multiplication of this value, right? So the X minus X bar into X minus X bar will be the X minus X bar the whole square, and these are the values what I get, okay. Then this is the summation value, okay. So as you can see, this is the sum value of this range, okay, as it is required, the summation value. So it is 1053523, okay. Now similarly I have to calculate X minus X bar into Y minus Y bar. So these two, I have to multiply these two terms, or these two rows, right, or these two, yeah, these two values. So this is what I get, okay. And then again I have to find the summation. So this is the summation value. As you can see here, it is sum of the range from F2 to F16. This is what I get, and this is enough for us to calculate what beta 1, right? This is enough to calculate beta 1. So with this, first let me calculate the slope value. So what is nothing but this formula, isn't it? Beta 1. So I have summation of X minus X bar the whole, X minus X bar into Y minus Y bar, which is nothing but this value, okay. So it is let me make use of the Excel formula, this divided by, it is divided by X minus X bar the whole square, so which is nothing but this value, right? Okay, now if I press enter, so this is the result, that is 139.4811. So this is the slope value what I get, okay. Now using the slope I should be able to calculate beta 1 also, or intercept. So beta 1 is something what we have calculated. Now I should be able to calculate beta naught, which is nothing but the intercept, okay, which is very simple. So I have to take a beta naught to the other side, so which then the formula becomes beta naught is equal to Y minus beta 1 into X. So first thing first, I have to make use of the formula, is equal to Y, which is nothing but currently I'll be using the mean, okay, then minus the product of beta 1, which is slope, into the X value or X mean value, which is nothing but this value, right? Okay, then if I press enter, this is the answer what I get, that is it's a negative minus 54191. So this is the intercept value what I got, okay. So we got the slope as well as the intercept. So using this I should be able to calculate the y hat a y hat value, that is a predicted y value. So this is already calculated. Okay, you just have to apply it in this formula. This y becomes y hat, and this is what I get. Okay, and now again we have to evaluate our model, right? Evaluate the model, and also we have to check how well the independent and dependent variable are correlated. So for that I need to calculate the r squared value and r value, so for which I require to apply this formula. So I have everything now. We have calculated everything. I just have to apply. I just have to make use of these values. Okay. So y hat minus y bar value. Okay. So this is what I get. This is what I get. And then I have to square it. So if I square, so just have to square this. Okay. So y hat minus y bar the whole square, then this is the value. Yeah, so these are the values what I get. Then I have to perform the summation. So as you can see, it is nothing but the sum of the range from here to here. So this is the value what I get. Okay. Similarly, the other value what is required is y minus y bar the whole square. So that is already calculated, as you can see. So it is already calculated. Okay. So let me calculate the y squared value, which is equal to this value divided by this value, right? Okay, so if I press enter, so this is, okay, sorry, it is the other way around. It is this value, yeah, it is equal to this value divided by this value. Okay, yes, my bad. So now it is correct. So I am getting 0.794 as the r squared value. Okay, so this is how much? This is around 79% efficient. Okay. Okay, from this I should be able to very easily, I should be able to calculate the r value, which is equal to, or which is nothing but the square root of r square, isn't it? It's a very simple formula. Okay, yeah, just a typing mistake. SQRT of this value should be able to give me the r value. So this is r value is 0.891123. Okay, so we have all the matrices now. So this is how we have to solve the problem, and this is nothing but, I mean, the calculation looks very heavy here, but we have just have to apply the same method what we have applied to the previous problem. So I should be able to get this value. Okay, so this is about the solution for the problem that is given in the textbook. And now I will show you how I can very easily automatically I should be able to make use Excel as a tool to get the solution, and also we can verify whether our answer is right or wrong. Okay, so we'll see that very soon. Now let us see how we can make use of Excel as a tool to obtain the result for any kind of regression problem. So I have the same problem x and y. Okay, so I have to select this, then I have to click on data here. Okay, so in data I have here on the right side I have data analysis tool. I have to click on that, then here I have to select regression. Okay, I have to click on OK, then I have to select the input y range. Okay, so I have to mention that. Okay, so this entire range is here given here. Then again I have to give the input x range, so that is also specified. So these are the ranges what you have to give. Then the output range, okay, so which I have to mention. I have to click on this, and I have to select any one empty row or empty column rather. Okay, so I'll give D. So here I should be able to get my result. And if you want the plot, you can give the plot also, which is not required. Anyways, we can very easily we know how to plot the graph using Excel also, right? I just have to click on OK. then I'll get the detailed result. So see, as you can see, this is the R value. So the same value what we got, right? See, as you, if you observe, this is the R value 0.891123, and same thing, same value we got, and R square value also, which is 79%, the same thing what we got. So this is how my how I can use Excel as a tool to obtain the results as well as evaluation metric, or how I can check the R square and R value to judge the efficiency of my solution. Okay, and also to see the correlation of the data between the independent and dependent variable. Okay.
Yeah, based on the solution, the house price can be represented with this formula. House price is equal to minus 54191, which is nothing but the intercept value beta naught, and this is beta 139.48, and into size, right? So given a question, size is equal to 2000 square feet in terms of area, what is the price? So very simple, I just have to apply it in the formula. So I'll get the answer as 224769. So this is the solution. Okay, so just have to apply it in the formula what we got, and the only thing what we calculated is we had to calculate is beta naught and beta 1. Okay, now let us look into something new, that is logistic regression. The logistic regression measures the relationship between a categorical dependent variable and one or more independent variables. So till now we have assumed that regression is all about calculating continuous value, right? So that is what we have, that's the problem what we have solved, like price is a continuous value. But the logistic regression is used to find the relationship between categorical dependent variable and one or more independent variables. So it can be used in problems like classification. Okay, example, heart disease prediction, predicting whether the person is having a heart disease or not, or other classification problems like determining whether to approve a loan to the applicant or not. So such kind of problems can be solved using a logistic regression. And logistic regression model use probability scores. So this is a very important term, probability. So everything is based on probability as the predicted value of the dependent variable. So logistic regression takes a natural logarithm of the probability of the dependent variable being the case, and we call this as a logit function. And let us, yeah, with the diagram we'll see what exactly a logic function is. The logic transformation is used in the logistic regression as a dependent variable. So we will be having diagram something like this. Okay, so logic function is, so in a linear function we always try to fit a straight line or a line into the various data points, right? But here we make use of the logit function, which is always which will shaped in terms of s. Okay, so the curve of the s may vary. Okay, so let me give an example how this logit function works. So I have to, okay, so I have something here. So I have a logit function also here. Okay, so I have here the problem being a binary classification 0 and 1. Here I have the weights of the mouse. Okay, I have weights of the mouse which is given as independent variable, and based on this I have to determine whether the mouse is obese or not. Based on this I have to determine whether the mouse is obese or not. So what I have to do, I have to make use of this logistic regression, which makes use of the probability. And this is on the y-axis I have weight. Okay, and these are already determined data. So these data points determine obese mouse. Okay, and these are the not obese. And here I have probability. Okay, I have the probability, so this may represent 50%. So given a weight of a very heavy mouse which may fall somewhere around here, then based on this curve I can very easily say, based on the curve I can say that there is a high chance that this mouse is obese. Okay, so this can be with a greater probability I can say that this is obese. So what if I have somewhere around here intermediate value? Then see this falls in the slope of this curve, right? So I can say that this mouse says 50% obese, or there is a 50% chance that the mouse is obese and the 50% chance that the mouse is not obese. Okay, and here if the weight is given somewhere around here, then I can say that mouse may be around 75%, there is a chance that it is obese. And if I give a very lightweight mouse, then I can based on the curve I can say that it is not obese. Okay, so this is how the logistic regression works. Okay, so this unfortunately we don't have any problems to be solved with respect to logistic regression in our syllabus. So this is only the work explanation of the working of the logistic regression. Now finally let us look into the advantages and disadvantages of regression. What first advantage is regression models are very easy to understand as they built upon the basic statistic principles such as correlation and least square error. So these are the concepts what we have already learned from the time when we know statistic, right? So it is very easy to understand, and uh, just this regression models provide a simple algebraic equation that are again very easy to understand and use. Second point would be the regression models can match and beat the predictive power of other modeling techniques. So I can say that it's very highly efficient with respect to its predictive power. Then the measure of the strength of the model, that is the goodness of the fit, is also very easy to understand. As we have already seen, right? We can measure by using R, the correlation of the coefficient of correlation between the independent and dependent variable, which the concept is very simple, or I can make use of R square to determine the goodness of the fit. So again, a very simple concept. Then regression models can include all the variables that one wants to use. Regression model tools are widely available. This is something what I've already demonstrated. Using an Excel also, I should be able to evaluate a regression model. I can draw the graph, or you can make use of other tools like GeoGebra, which is a graph tool, or I can write coding also, right? I can programmatically I can solve the problem by using Python or R language. Now let us see some of the disadvantages. Regression models has data quality issues. So the data need to be very properly prepared. I shouldn't have any missing data. So this will cause some problem with the efficiency of the regression model. Then regression model suffers from collinearity problems. So what is collinearity? So this is a term which means there is a strong linear correlation among the some independent variables. So if the independent variables have strong correlations among themselves, then they will eat into each other's predictive power, and the regression coefficient will lose their ruggedness. Okay, so this is the problem, and regression models can be unreliable if a large number of variables are included in the model. So this is also one problem with respect to regression. And regression models do not automatically take care of the non-linearity. So something what user have to or the programmer has to take care of before applying the regression model. Then finally, the regression model works only with the numerical data. Not so true with the logistic regression, but in most of the regression algorithms are requires numerical data to calculate, since we are using statistical model, we require a numerical data to perform, uh, to apply it in the formulas or to apply the algebraic equations, right? Okay, so these are some of the disadvantages of regressions. So with this, we will come to the end of regression and also module 4. I'll see you all with the next one. Okay, bye bye.